This is Honors Geometry, Note Section 14.4, finding the area of regular polygons. Now there is a kind of complicated formula that goes with this, but if you don't like this formula, then you can just find the area of a triangle over and over and over and over and over. Let me explain. First of all, there's a definition. It's new, and that's called an apothem. That's not me mispronouncing it. It's called an apothem. An apothem is a segment that goes from the center of a regular polygon to a side forming a perpendicular. So here's the center. We got the segment, it hits a side, and it forms a perpendicular. That's an apothem. For the time being, let's just ignore that for a second. Let's look at this picture over here on the right. This is a regular hexagon. And let's just focus on finding the area of this triangle right here. Find the area of this triangle. We're going to take 1/2 base times height. So let's say that this height here, we'll just call it height. And let's call this base here, we'll just call it base. So the area of one of these triangles is 1/2 the base times the height. Well, how many triangles are there? Well, in a regular hexagon, there are 6 sides that are the same length. So it's going to be 6 of these. So the area of this hexagon is going to be 6 times 1/2 times the base times the height. Now work with me here. I could simplify the 6 times 1/2, but this could be any shape. If you focus on 6 times the base, now the term that we used earlier was perimeter. This hexagon has a perimeter of a base plus a base plus a base plus a base plus a base, plus a base, 6 times the base. So we could rearrange this and say it's 1/2 6 times the base, this is the perimeter, times the height. We just defined what I just called the height here as the apothem. And that gets us to this formula right here. The area of a regular polygon is 1/2 the perimeter times the apothem. 1/2 the apothem times the perimeter. If you don't care for that, once again, you don't have to use this formula. If you prefer, you can find the area of that blue triangle, multiply it by how many there are that are congruent to it, and that's going to be the area of this regular polygon. Just to remind you, the measure of a central angle of a regular polygon, and that would be like this angle right here, is 360 degrees divided by the number of sides. So let's try using this formula. We are to assume this is a regular figure, even though, like on a test, there should be some type of words or symbols that let you know it's regular. Well, to find the area of a regular figure, it's 1/2 the perimeter times the apothem. The perimeter, in this case, is going to be 8, that's the length of one side, times the number of sides. It's got 1, 2, 3, 4, 5, 6, 7, 8, 9 sides. So the perimeter is 72. Do we know what the apothem is? Sure looks like it's 11. It goes from the center to a side forming a perpendicular. It's going to be 36 times 11, which is 396. We weren't given any unis for this, so we'll just say it's square units. Had you found the area of that triangle and multiplied it by 9, you would have had similar results. Let's check out this one over here. This one has a lot more happening because they give us a lot less information. The first problem, it gave us more than we needed, quite frankly. This one, just getting dirty, only giving us the bare essentials. We know that the radius of this regular polygon is 13. That's the distance from the center to a vertex. We don't know the length of the apothem, and we don't know the length of a side to find the perimeter. So we got a lot of work to do. I would suggest that you start out with a measure of a central angle when you're given such little information. Central angle is 360 degrees divided by the number of sides. This is a hexagon. There are 6 sides. So a central angle is 60 degrees. Although the central angle is 60. Now let me just show you what that would be in here in this case. If I take this central angle here, it's 60 degrees. What we're more concerned with is when we drop an altitude in that triangle. Keep in mind, since the radius never changes, this is a minimally an isosceles triangle. When you draw a altitude from the vertex angle, it always cuts the angle in half, always cuts the opposite side in half. This just gave us a right triangle, and keep in mind, if it's cutting the 60 in half, it's going to make each of these 30. So this is 30. If we wanted to draw it on this other side, it'll also make this 30. We're really concerned with this right triangle right here. The hypotenuse is 13. This is a special right triangle. Opposite 30 is going to be half of that. That's the short leg, which is 6.5, which makes the length of this whole thing 13. If opposite 30 is 6.5, opposite 60, so it's the short leg, times the square root of 3, it's going to make the apothem 6.5 square roots of 3. If you're wondering how to say apothem correctly, you stick out your tongue, you grab it with 2 fingers and your thumb. I mean, not right now because of, Corona. But if it wasn't Corona time, you would hold that and you would say opossum. If you successfully can hold your tongue without giving yourself the virus and say opossum, you would get apothem. Find the perimeter of this because the formula uses it. The perimeter is going to be 13 times 6, which is 78. The area of a regular figure is 1/2 the perimeter times the apothem. That's 1/2 78 times the apothem of 6.5 square roots of 3. That's going to give us 253.5 square roots of 3. And we don't have units, so it's square unis. That did not work out the way I expected it to. Look at that. Alrighty. Let's just practice finding some central angles of these other shapes. Now, depending on the information you're given for a triangle, you might not even use a regular polygon formula. But if you were so inclined, depending on the information that you were given, the central angle is going to equal 360 divided by the number of sides. This is a triangle. The number of sides is 3. Means the central angle is 120 degrees. For a square, and once again, you probably wouldn't use this formula, but there's times where you might. The measure of a central angle, 360 degrees divided by the number of sides. A square has 4 sides. So we would get the central angle is 90 degrees. For a pentagon, measure of the central angle is 360 divided by 5, which is 72 degrees. Another friendly reminder, special right triangles, Pythagorean theorem, trig functions, those are all fair game, as they say. Let's try it. Find the area of the following regular polygon. So the directions were good this time. They told us these are regular. It's an octagon, so there's 8 sides. We want to find the area. It's 1/2 the perimeter times the apothem. Well, the perimeter, there are 8 sides. Each side has a length of 6, so the perimeter is going to be 48. They clearly tell us the apothem is 4. So 1/2 of 48 is 24. 24 times 4 is 96. The unis here are square feet. I mean, that's as easy as it gets, assuming you know the formula. But you will not be so lucky as to be given that information. Number 6. It's a triangle. We could take 1/2 the base times the height, but we don't know the base, nor do we know the height. If you don't know the apothem or the base or the height, you want to find the central angle first. That's what I would suggest. Central angle is 360 degrees divided by the number of sides. That's going to be 120 degrees. Remember, when you draw the apothem, it cuts that central angle in half. So 1/2 of 120 makes this 60. Hey, special right triangle. Imagine that. If opposite 90 is 10, the short leg is 1/2 of that, which is 5. Our apothem's 5. If the short leg is 5, the long leg is 5 square roots of 3. And there are 2 of those that make up the side. So the perimeter for this has 3 sides. Each side is 10 square roots of 3 long, so the perimeter is 30 square roots of 3. To find the area, which is 1/2 the perimeter times the apothem, the perimeter we found is 30 square roots of 3. The apothem, which is right here, is 5. 1/2 of 30 is 15. No, it isn't. Yes, it is. 15 times 5, that is, carry the 1, that's 75. We know unis for these, so the area is 75 square roots of 3 square unis. Number 7. The directions said the irregular figure. This is a hexagon. Perimeter is going to be pretty easy. 6 times the number of sides, so the perimeter is 36. Since we don't know the apothem, let's find the measure of a central angle, which is 360 divided by n. N is 6. 60 degrees is the central angle. The apothem always cuts a central angle in half, which makes that 30. Always cuts the opposite side in half as well. So if the opposite side is 6 and it's cut in half, that makes this 3. If that's 3, the long leg is 3 square roots of 3. So the apothem is 3 square roots of 3. To find the area of a regular polygon, it's 1/2 the perimeter times the apothem. The perimeter is 36. The apothem is 3 square roots of 3. This is going to give us 3 times 36 times 3 square roots of 3. Let me put that in my calculator real quick. That is 54 square roots of 3. And we have units for this one, square feet. Lovely. Number 8, a regular pentagon with a perimeter of 40. Well, the area is 1/2 the perimeter times the apothem, and we already know the perimeter is 40. I'm going to make a drawing for this. If the perimeter is 40, and there are 5 sides, if I take 5 into 40, it's going to go 8 times. I'll show you the work for that. Perimeter is the number of sides times the length of a side. Perimeter is 40. The number of sides is 5. It's going to make the length of a side 8. I would want to find a central angle. It's 360 divided by the number of sides. There are 5 sides. It's 72 degrees. And Apothem cuts a central angle in half every time. Half of 72 is 36. The Apothem cuts the opposite side in half, so that makes this 4. Gonna have to use some trig to find this Apothem. Tangent of 36 degrees is the opposite leg over the adjacent leg. If I multiply both sides by y, I get y times tangent of 36 degrees is 4. If I divide both sides by tangent of 36 degrees, and I throw that into my calculator, I get 5.51 is the Apothem. A half of 40 is 20. 20 times 5.51 is 110.2. The units we had here would be centimeters, so it's square centimeters. Almost finished. Some reminders. 3-sided figure is a triangle. 4-sided is quadrilateral. Yada, 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 yada. 11's an undagon? That's news to me. Never heard that before. 12's a dodecagon. Anything bigger than 12, we just call her an n-gon. It's an n-gon. Got 30 sides, a 30-gon. It's got 41 sides, 41-gon. That's how lazy we are. Please do the homework that accompanies this. That would be section 14.4. Best wishes. 14.4. Best wishes.